Okay, hello everyone again. And I'm pleased to introduce you one more presentations for the healthcare topic. And we're having our next company, next speakers, TCC Case Mix Limited. And I would like to welcome Dr. Matthew Bacon, Chief Executive of TCC Case Mix, and Jack Morwood, Mathematical Modeler. So welcome everyone, and here we go. We can start the presentation now.
Hi. Yeah, I can't see the slides, so. Thank you. So sorry about that. Introduction. Got it. So yes, Matthew Bacon from TCC Case Mix. Good to be here this afternoon. Jack with me, as you heard, is our mathematical modeler. And we have been undertaking an innovative piece of research about how we can better bridge the divide between our customers, who in this case are in the surgical services delivery pathway of healthcare, and where they have deep expertise, obviously, in their work, but little knowledge of simulation modeling, and certainly not the ability to interact with a simulation. So, Jack, if you could move to the next slide, please. So our agenda today, I'm going to put the context of the simulation work we've been doing in a business context to explain the broader reason why we've been modeling in discrete event simulation and agent-based simulation so a mixed method within surgical services delivery. And then Jack is going to explain how we've implemented that and the value of using AnyLogic in the process. So next slide, please, Jack. So the business challenge that we've attempting to solve here, we have solved indeed, is that surgery today is highly unpredictable in many parts of the world. And it's unpredictable because traditionally there's been a lack of data in order to inform planning. And the need is to improve productivity in surgery. And we've developed in TCC Case Mix a unique proposition, which is one to acquire data about surgical services delivery in real time in the operating theatre. And it's in that data acquisition process that we've been able to use that data to inform our simulation work. So next slide, please. Can I have the next slide, please? Thanks. Okay, so this is the broader context for the work that we've been doing. And you can see here presented is what we call the digital pathway in elective surgery. And across the top of the slide are the major stages of that pathway, which, as I say, are all digitally enabled. So it's an exemplar of the whole pathway. That's what Case Mix is about. And on the left-hand side of the pathway, you can see the entry into it by the patient coming into a preoperative assessment process. And at the right-hand end of the pathway is where they will leave surgery and go into post-operative care. And it's the focus that you can see highlighted in the screen here, where we are using AnyLogic to better inform the planning of surgery. Because it's one thing to improve delivery within surgery, which is what we've been doing in CaseMix. We've been doing this by the unique data acquisition process that I've mentioned. I'll explain a bit more about that just in a moment. But it's the challenge really is how to manage all of the factors around surgery which impact what happens in the operating theatre. And that's where we're using the simulation to experiment with those variables. What's unique about what CaseMix has done is to be able to measure the impact of the inputs to the process. In this case, it's the patient. What are the patient presentation, the various aspects, what we call the comorbidity, the risks that they present to surgery, and risk stratify the patient relative to what are the known duration impacts within surgery itself. So we've joined those two parts together, which has never been done before in the way that we've done it, and we're using machine learning algorithm to create these risk cohorts. So that's the context for the use of CaseMix. If we could go to the next slide, please. I think while I'm waiting for this slide to come up, okay, it's here. So before I explain this, the simulation work that we've been doing, I want to position it in a historical context. So very quickly, because we've been losing a bit of time over the problems of the presentation slide flow, but there you go. I wanted to explain that we see a history, we all know the history of simulation in healthcare, and it goes back a long time. It's in recent years that we've seen the move to discrete event simulation, but the literature reviews that we've studied and our own examples that we've seen in various conferences really point to the fact that they struggle with an acceptable reflection of the real world. And we believe this is largely because there are many assumptions that have to be made in surgery, and those assumptions get made because of the lack of data. And so what we find is that typically in the simulation, one is attempting to reflect the real world with its assumptions. And as I say, because those assumptions happen in various different ways, well, then how can we have a reliable and predictable simulation, which is what we're trying to achieve? So the proposition is to reverse that logic. And we do that by enabling the customer to experiment with all the parameters that impact the simulation, impact the environment that they're working in, and set those variables as constraints in the system. They then experiment with those constraints. And so we end up in the situation where actually the real world now follows the simulation, because the simulation is setting the parameters in which the real world should implement. That's essentially what we've set out to do. And so the problem that, as you can see here, and we can race through this, I think, where the slide is showing about the data collection, we'll need to carry on with the build, please, is that we've lost... So we're jumping around here. So in the previous slide, the message was that we don't have any predictability because of that lack of data. And what we've shown here in box 1 is the risk stratification of the patient with their data. And it's the risk stratification that enables us in box 2 to better inform the simulation. And to do that, we acquire the data in surgery and use a feedback loop with a statistical analysis to better inform the planning. And so it becomes a circular loop. And the end result in box 3 is showing that we can then deliver the predictability that we've sought.
Hi, Matt, just testing my audio.
So if you could move to the next slide, please. Could you move to the next slide, please? So what you can see on this presentation is that we've been acquiring this deep data, and we're able to risk stratify patients into these cohorts and create these narrower distributions. So rather than a general cohort of patients and being distributed, which is what leads to the great variability, in our case, what we're doing is narrowing the risk factors, and through that process, focusing on specific patients and therefore the variability associated with them. And that gives us that narrow distribution, and that's what feeds into our logic. So if we could go to the next slide, please.
Hi everyone. So thank you for that, Matthew, and I'd like to move on now and begin talking you through why we chose AnyLogic. So first, we'll have to deal really with two perspectives of how AnyLogic has delivered value for us. So the first are we, the simulation experts, and the second are our customers, who are surgical services team seeking to improve their productivity. And it's important that we make this distinction because these two groups of stakeholders have very different needs and different requirements. So first, for case mix, we have very technical needs concerning developing a simulation service. So AnyLogic needs to be able to deliver a powerful simulation service in a really configurable environment that reflects the real world. And we need a hybrid simulation combining agent-based simulation with discrete event. And that simulation needs to be able to scale to complex, multi-specialty surgical pathways and integrate with our database, as Matthew mentioned earlier. For our customers, on the other hand, these are clear usability needs. So the simulation has to be usable by this group who are not necessarily experts in simulation. So we need to create an intuitive user interface and put the simulation tool directly in our customers' hands. This can demystify the simulation environment because everything is guided by the customer in control of inputs and outputs. We don't need a simulation expert in the room for the first time. Now, can you imagine how powerful this will be at workshops, multidisciplinary team meetings, or just everyday surgical planning guided by consultants? And just a few examples. So CaseMix has created a series of cloud acquisition tools that provide data to a database. Well, it's this database that parameterizes our agent population in the simulation. And this is a major source of value for us. And only AnyLogic could allow us to import this around TCC CaseMix's custom data schema. Similarly, for our customers, we've been able to use AnyLogic Cloud to run the simulation directly in the web browser and put it in their hands. We're really excited that later this year we'll be moving to AnyLogic Private Cloud. Flipping back to CaseMix, part of the simulation involved list optimization, and we implement this in an AnyLogic event module. Now, because AnyLogic runs Java, we simply compiled our list optimization engine in Java and imported it directly into AnyLogic. This configurability has completely changed the way we deliver the simulation because we have complete control over what is really complex behavior. And not just that, but we can change this logic and test alternative optimization engines. And it's because we use AnyLogic that we have this level really of complete control. But the bottom line is this. Thanks to AnyLogic, we can meet all of our simulation needs. So then, what's significant about what CaseMix has achieved with this simulation? Well, for the first time, the user has the ability to control and investigate the outputs of the simulation without the need for an expert to be present. We're able to use the simulation to directly quantify the tangible benefits from improved list optimization delivered by CaseMix service. And in the KPI dashboard, you'll see here, the user can pass performance data, be that different temporal resolutions, so day and week views, data about predictability, procedure duration, overtime use, which is a key operational constraint that we deal with, data about budgets and costs and waiting times, and users can download all of this performance data for custom analysis. This is made possible by the database logging, which is quite distinct to AnyLogic. Now, can you imagine how powerful this KPI dashboard is when it's in the hands of our customers, who are completely in control of the inputs and outputs and can investigate the impact of different constraints and operational policy and resource sets? Moving on to a few of the benefits specifically, there are tangible benefits and intangible benefits. So we pass on two things to our surgical services managers. First is empowering them to make better decisions. That translates into something very tangible around their constraints, their KPIs, the level of predictability. But the intangible is the learning experience, the impact, knowing the impact of their parameters and their impact. And when we put this in front of surgical services teams, we hear just how impressed they are at the confidence and the understanding that our simulation service can deliver. And we pass that on to others. We pass it on to clinicians, to patients, and to society. Now, I'd like to provide a brief demonstration of our simulation service. And in this example, we're going to be using single specialty data from a hospital partner in Hungary who CaseMix has worked with over the last 12 months. So I'll just talk about the start of this process. So we use MATLAB to prepare data for the simulation. So this labels each patient with a mean and a standard deviation according to procedure complexity derived from their characteristics. And this is really an important step, and it's something we've been able to achieve complete interoperability between MATLAB and our AnyLogic workflows. They're highly complementary, and again, this is more value that AnyLogic is providing. Two things take place. Data quality analysis ensures that the data underpinning the simulation service is really robust and excludes any outliers. We cleanse the data. The risk factor cohorts are then created from the statistical analysis, so it provides that mean and that standard deviation. This greatly reduces variability. Now, moving on to our AnyLogic model, see here the user interface. So we're putting this directly in the hands of our customers. So making this interface as user-friendly as possible was an absolute must, and it's one that we've delivered. So from this main screen, you can toggle simulation settings, such as the ability to edit resources during the simulation. And you'll see on the left-hand side, this is our main user navigation. And you navigate through a series of panels. So the first of these panels is the unscheduled pool. So here we import patients from the CaseMix database, and you'll recall that Matthew pointed to the scope of the simulation and what goes on up to this point. Well, it's from this data acquisition process about patients and about their operation duration that we obtain the unscheduled pool. Next up, you'll see our resources panel. So here the user is able to control some basic parameters about how resources in surgery are used. So when lists take place, how many per day, how many per week, and this produces an availability schedule for each of them. Now, the user can input how those resources are used, but what about the resources themselves? Well, this is done using the AnyLogic database. So we describe in that each country, region, group, hospital, and specialty, importing each as a resource and storing them as an agent. You'll have noted that this goes right up to the country level, and this comes back to delivering scalability and envisaging that in the future, we'll be able to optimize surgical pathways at the whole system level and for entire regions. You may have also noted that this powerful resource configuration is actually delivered in quite a simple way, and it comes back to making our simulation service on the forefront, just intuitive for our users. The same applies to our next panel, so KPI targets. These are divided into productivity, arrivals and changeovers, and cancellation KPIs. So productivity KPIs describe the volume of surgery specific to resources or temporal resolutions, and users input a baseline and a target level for that. For arrivals or late starts and changeovers, we model each according to a mean duration and a standard deviation. We initialize this based on our historical data, but we can set targets for its reduction to see what impact, for example, a 20% reduction in changeover time could have. Last of all, we have our cancellation KPIs. Now, these emerge directly out of a co-production process with surgical services managers who pointed to patients who either just didn't attend surgery or had to cancel for clinical reasons. For example, they tested positive for COVID-19, and we adapted our model to incorporate this behavior. Moving on to list optimization. So there are some key inputs to this which are really important. So the confidence factor describes the acceptable likelihood of overrunning by a particular amount of time, which we call our confidence threshold. So for a confidence factor of 0.75 and a threshold of 20 minutes, the optimization engine would create case mixes so that you could be 75% confident of finishing within 20 minutes of the list duration. The planning horizon, interval day of week, they just describe when the planning takes place. And planning itself takes place according to a triage process. So priority patients who need elective surgery within that planning horizon, who were assigned first. And after this, non-priority patients whose target date for surgery falls outside of the planning horizon when they're scheduled. Finally, our simulation logic uses a discrete event simulation to recreate the behavior of the entire surgical pathway. That's from patient preparation right through to leaving for recovery. We model our resources, we produce statistics for our KPI dashboard, and measure overtime use. Now let's just look at our demo in some context with a few in-practice examples. So we were asked by an integrated care system to assess the impact on productivity of planned absences over the summer in an acute care trust. Now to do this, we needed to assess how many additional surgeries could have been performed in a 4-week period had this capacity been used. The simulation was really useful for this, and because we could configure the resources for a baseline and an alternative scenario where productivity was being used appropriately. So in the instance of the baseline, with only 5 surgeons available for 2 5-hour lists per day, 82 surgeries were completed, and we were able to inspect the log and post-process simulation data to create really rich analytics about this. Now for the alternative, where the surgeons were all available, we had an uncapped target list and 3 4-hour lists. Instead, 204 surgeries were completed. Here, each theatre was used much more productively by organising its 3 lists with all surgeons available. We more than doubled the number of surgeries completed. Now, another example. So let's say our 2 patients have tested positive for COVID-19 and can't attend their surgery. And this was a really important effect to capture, as it really has affected real-world practice in the last year. Indeed, in some healthcare systems, cancellations are notoriously high. Now, we get the same data as before, but now we can also see there are 13 cancellations in this period. Now you say, what do we have to do? And, we've had these last-minute cancellations, and surgery is a precious resource, so we shouldn't be wasting it. Now, with our case mix optimization logic developed in AnyLogic, we simply take this down to a lower level. We run the simulation, and we find the optimal patient to fill that latent capacity. And that's where the database output comes in. We just give the Excel file to the surgery planners to use. 3 patients have been fitted on a list rather than 1 previously. And that's 2 additional short procedures and the latent capacity used in full. So the business challenge that Matthew defined earlier, we've solved it. We've joined up this process using our data acquisition technology and using AnyLogic, and have been able to use that data to transform surgical services. Now, before we move on to questions, we're pleased to be offering both case mix service system optimization and case mix service list optimization. So 2 different levels, one for entire patient pathways and the other simply for surgical services teams in a single hospital. And this is in addition to the data acquisition technologies that Matthew outlined earlier, and this delivers a truly joined up system. So thank you very much for attending our presentation, and for the AnyLogic team for hosting this conference and the opportunity to present today. Thank you.
Thank you. Thank you, Dr. Matthew. Thank you, Jack. And I would suggest to go to the Q&A session, as long as we already have some questions from Antoela Taco. And
are you okay?
And the first question is, how do you engage the service providers in understanding and designing your model?
Sorry, can you repeat that? I got a lot of distortion on the phone, Daria, on the line.
Yes, sure. How do you engage the service providers in understanding and designing your model?
Okay, so the engagement actually comes through two routes. The first is that where the surgical service provider wishes to optimize delivery, then there'll be licensing case mix. And what we then bring into that sales process is the ability to then demonstrate the value of that data. Because there's always the question, it's one thing delivering in surgery, but what about the broader aspect? So the two go hand in hand together. And we also use it in our sales process as well to demonstrate what they can achieve from these simulations.
Thank you. Thank you very much. And the second question from Antuela is, how has been the model used by your clients, and what has the impact within the services you work with?
Yeah, so at the moment we are at a very early stage with this process. So we've only recently launched the technology, but so it hasn't been used in earnest yet. But we've got work that we're planning, for example, in Hungary, where the Ministry of Health has seen what we're doing and wishes to use it as part of a national improvement program. And it's a way then of engaging with people in different countries over the cloud, and we can then run the consultancy from wherever is appropriate. But in Hungary, we'll be doing it locally with our team.
Okay, thank you. I can see one more question from Mr. Alvaro Gil. How many replicants do you consider necessary in order to achieve a valid confidence interval?
Okay, so we know that we have a surgical data acquisition process. The first stage, it's usually between 3 and 6 months, and the amount of patients we will put through that process is around 300 to 500 patients, and within that number, we've found that we can get some statistically reliable results from that.
Okay. So we don't have any more questions, and our time is almost ends. So I would like to thank you, Dr. Matthew, Dr. Jack, for your presentation, for being here with us at the AnyLogic Conference. So thank you very much, and see you today at our discussion boards, at our activities.
Yeah, we had a bit of a problem earlier on, but we tried to manage through it, didn't we? Yeah. Anyway, thank you. Really good.
Thank you.
Bye-bye.